All right, welcome back everyone to another edition of the Sourcegraph podcast. Today I'm talking with Max Brunsfeld. Max was one of the core contributors to Atom, the hackable web editor that pioneered the use of Electron for desktop applications. He is also the creator of TreeSitter, the modern parser generator tool that powers syntax highlighting in an increasing number of editors and is also used for code navigation on GitHub. He's now working on something new, a project and company called Zed, which is trying to bring real-time collaboration into the editor, taking lessons learned over many years working on editors and developer tools. Max, welcome to the show.
Thanks, Beyang. I appreciate you inviting me on.
Awesome. So we like to kick things off around here by asking people, how did they get into this world of computers? So Max, how did you get into programming?
Yeah, it took me a long time. Growing up, I wanted to be an artist of some sort. My father's an artist, and both my parents are really. And I thought I wanted to be some kind of realistic illustrator or jazz musician. And we're all kind of in the technical sphere of the arts, but I didn't really think of it that way at the time. And so when I went to college, I started out studying art and music, and I did kind of know that I hadn't yet found the right path. I hadn't found something that I was really good at and that was going to be a reliable way for me to take care of myself. And I was lucky that I went to a small college that wasn't where most of the majors weren't super competitive to get into, and it wasn't super elite or very expensive. So I was kind of able to just keep changing my major until I figured out what I wanted to do. And so every semester or two, I kept on changing what I was studying. And eventually I ended up taking a calculus course. And it was when I took that class that I kind of realized I had always just identified as an artist, not really thought of myself as a super scientific person. But when I got into that class, something about it was like the first time I had learned a new technical set of ideas as an adult. And there was these three things, the derivative and the infinite series and the integral. And it all made so much sense. And I just remember thinking wow, this is what scientists, kind of the stuff that they do all day. They sort of build these theories that make sense. And I was just it felt incredible. And I was and I am I get this. I'm actually good at this. So it was like I had finally, I couldn't believe that I didn't realize before that engineering and science were so cool. And that was a couple of years into college, but I took, for a couple of years, a combination of classes in environmental engineering and physics. And I eventually got my degree in physics. And so by the end of college, I had done at least some programming, because in engineering school, we had these numerical analysis classes where it was very old school though. The professor would write on the blackboard the Fortran program and prove that it was solved the math problem correctly. And we would email the computer programs that we wrote as our homework to our professor, and he would print them out in a red pen, underline the bugs. And it was so different from, what I think of programming is now, with all the tools and the methods. And I did realize in college that I liked that, but I still didn't, when going through all that, didn't think of myself oh, I'm going to be a programmer now. It was just something that felt easy, and that, unlike doing lab work or having to procure materials to build something, you could just it was kind of limitless what you could build. And I really appreciated that about it. But I still didn't say to myself, oh, I'm going to be a programmer. And what it finally took for me to get there was really meeting the right person, a friend who was passionate about programming and who could I could talk about it with in a way that made sense to me. And so luckily, my girlfriend at the time, who I'm now married to, her brother is a software engineer, Nathan Sobo, and I met him during we hung out during my senior year of college, and he had already been working as a software engineer for a few years, and he had quit his job to work on a side project that was kind of a passion of his. I won't get into too much what it is, but it was this like it had this mathematical component to it because it had to do with voting. There was like these election algorithms that were involved in this product that he was building. It was he had this idea for like exploring these new ways of like collective decision making with voting online, and he was basically taking time off to explore this idea. And when we were hanging out, he said to me, "Oh, Max, you do physics. You're kind of into like reading like mathematical stuff. Like maybe you would be interested in kind of researching with me this literature that exists about election theory and different algorithms for computing election results, and we could code together." And it was so funny because at the time I was like figuring out what I was going to do after college, and I was like thinking about applying to material science grad school or things like that. And so I almost had this reaction of like, oh no, I don't have time to do this. I need to figure out what I want to do with my life. And luckily I stopped and was like, oh, well, maybe this will help me figure out what I want to do. And so he shared with me a GitHub repository, which was like, it was a new thing to me at the time. This was 2011, I think. It was in college still. And so I began to read about these election algorithms, and he was developing an application that implemented these in Ruby at the time. And so I was looking up how to program in Ruby and to kind of adapt these algorithms into Ruby code. And we talked more, and he said, "Oh, wow, you're really engaging with this. Okay, well, maybe you and I should code together, and I should come and visit you." And I lived in Humboldt, California at the time, and he lived in San Francisco, and he came and visited me. And I remember we pair programmed. That was something that he was really into at the time, and I had never heard of it, but he had this, he set it all up. We had the 2 displays, and 2 keyboards, all this equipment. And and we sat down and we coded, and we ended up spending all this time pair programming together. And for me, my experience programming had been, like I said, in the engineering department at school with using very primitive tools. I was using VI, like the engineering lab teachers taught us to use VI, not Vim, but VI in the terminal. And so Nathan was we were coding Ruby. He had this Rails app. There was JavaScript. There was long polling. There was Postgres, just all this stuff. And he was using Git. And I was sitting next to him and kind of taking it all in through this pair programming process. And I remember I was just learning so much with all these technologies and tools for programming that I hadn't been exposed to. And we would take turns typing. Mostly he would type and I would just be taking it all in because there was so much. But I would type, and I remember one thing that he would do would be we'd decide to make some kind of change, and I would start typing, and he'd be like, "Wait a second. No. Just undo all that. You just typed I want to show you can use the tool to make that happen." And he'd be hit Alt F6, and first we'll rename this function, and then we'll extract this part into another function, also using some other command. We were using RubyMine at the time, the Ruby IDE by JetBrains, and there were all these kind of moves that he taught me to do. That was not just the programming knowledge itself, but the tactics of how you physically get the code into the files.
Yep.
And something about that at the time, I was learning all this kind of stuff about building applications, but then also learning that there was just these amazing tools that you use as a programmer, and that it was this craft, almost a trade, where you have to learn this rich set of tools. It was almost like an apprenticeship experience for me, a classic, learning, being a carpenter or something, but for code. And something about that, the experience of learning to code effectively with these tools, that was just amazing to me. When it just made me come to think of programming in a whole new light as this thing that it was like this skill that you could hone not only in your understanding of software, but your ability to like create software effectively and, efficient way that wasn't error prone.
Yeah.
And that was just mind blowing to me. That was the point where I was like, oh, okay. I'm going to be a programmer or software engineer or whatever you call it. Like, yeah. And so that was during my last year of college. And that was when I decided, I'm not going to apply to, engineering grad schools. I'm going to do this. And then the funny thing is, it's like, it's hard to explain what this actual application was that we were building on. It was, like I said, it had to do with like voting and democracy. It was a little kind of...
Was it like a voting system that people were going to use to vote, or was it more of like a research project? Like
it was more researchy, I would say. It was like an app to explore these ideas. But Nathan had, earlier in the year, Nathan had said, I'm applying, I want you to apply this thing with me in case we decide to keep working together. It's this thing called Y Combinator, and I'm going to see if they want to fund me to do this. And at the time, I was like, okay, I don't know what Y Combinator is, but I'll do this application with you. And then we had all this time coding together that I described, and then we got asked to come speak to them at Y Combinator for this idea that I have no idea how to explain how it would ever be a business. But like, Y Combinator does that. They mold your idea into a business or whatever. So it was like right after college, I was still feeling this total shock of like, going from an engineering school to like, startup like coding.
Yep.
And we go to Y Combinator and we like, wait with all the other teams. I mean, as you know, we got invited into this room to talk to Paul about it. And it was like, once we got in the room, like it was pretty quickly, it was kind of a shit show trying to explain how this thing was going to be a business. They weren't really like loving it, our explanation. But that's
a really like short meeting too, right? It's like 10 or 15 minutes that you have.
I remember it being very short. Yeah. And like I think when I knew it was going badly was when it just like turned all into like a tech. They started asking about like, oh wow, that's working in real time. Like, how'd you make that happen? And so like, it was kind of like at that point, it was clear that there was not much business like potential there, or it was at least going to be a difficult road to try to turn that into a business. But like the tech side of it was really interesting to them. So we got sidetracked onto that, and then like we pretty soon got a letter that said, "Hi guys, like really cool tech that you're building, but we don't see how we're going to make that into a business." But that was just a really early, interesting, trippy experience for me coming out of college.
That's awesome. So where did it go from there? What was the path from that to working at GitHub?
Yeah, so we spent a few months. So after college, I didn't know what I was going to do. All I knew was that I wanted to code with Nathan on his project for a while, and he had money. He was taking time off, so he was like, "I'll give you some money so you can eat. You can come." Just code with me. I like moved back into my room at my parents' house and like was just he was like borrowing a desk from his old employer at Pivotal Labs. The founder of Pivotal, Rob, was just kind enough to let Nathan and I like have a desk there and work on his thing. And so that I was there, I was coding with Nathan all summer. And then we sort of at a certain point decided to call it like, okay, we need to go get jobs now. And so, I applied to Pivotal and interviewed there and started working there after this. And the cool thing about working at Pivotal was Pivotal's like a consulting shop that they have this very specific service that they provided, which was if you wanted software built quickly and you wanted them to teach kind of your own engineers how to build the software, they had this integrated pair programming based practice for making that happen. And we would handle hiring for people. Like it was sort of what selling point was that Pivotal knows how to hire effectively and bring people on. And so it was like this sort of complete service for kicking off a project and then staffing up a team on it. And so it was very focused on pair programming all the time and rotating new people onto the project constantly. And so after having had this summer where I kind of had this crazy crash course in all the like practices of programming and how to do it effectively, like it was sort of an opportunity to go mix with all these people in a really rapid way, and learn and like do my kind of immediately start teaching other people the skills that I knew about how to code effectively. And I remember Pivotal, it was like there was a lot of the projects at Pivotal had a common approach. We were doing a lot of Rails apps with certain kinds of JavaScript that we would do. We'd do iPhone apps in Objective-C. And so we would use the IDEs for those languages, like I had learned, like the JetBrains suite of IDEs. And so there were all these cool things you could do to code effectively. And so all these pivots knew this, all these tricks to basically make, get code fast, and, make changes fast. And so I was picking those up. But then there was a certain class of projects at Pivotal where like the IDEs, there were like code bases too large to be opened in IDEs or code bases in different languages. And so there was like other pivots who would like had all this deep expertise in Vim and using all these like kind of lower level tools for coding.
Interesting. So they would use Vim on the larger code bases because like you would try to open it up in the IDE and it would like slow to a crawl or something like that.
Yeah, at that time, RubyMine couldn't open. I don't know what would happen, but you couldn't really open some of these client code bases in the IDEs. And so you had to, there's this whole other like kind of parallel knowledge base at Pivotal of like people who knew how to do crazy Vim. Like it was all this
dark art of
customization.
Vim. And
Right. And so I learned all of that as well. And with that was cool for me because I was interested in learning other programming languages too. I had learned a few on the job, but I was at the time I was interested in like Clojure and Haskell and learning functional languages, and there weren't the IDEs for those. And so I was really happy to be learning how to use these other tools like Vim. But while learning those, I remember it was so much work to like customize them and make them like usable, adding modern features to them, and also to learn all the commands that you needed to know to like change inside brackets and all these commands that people use in Vim to like edit pieces of text. And it's funny, like Nathan and I had all these conversations about like, while working on this side project, about like something else that Nathan was really interested in was like, he was like, one day I want to build my own code editor that's going to be like better than all these code editors. And one thing about it, it's going to be like the IDEs with all these syntax aware commands. But there's going to be incremental parsing so that it's fast. It's not slow like these IDEs. And it was kind of like a short, like that was the extent of it. What I like, took away from those conversations, but I remember that putting this idea into my head about, like incremental parsing, that makes sense that you'd want to do that, but like that isn't solved, or it was kind of like, and then I could see once I switched to using Vim, I could understand like, Vim doesn't really do like syntax analysis. It just, there's this really kind of rough syntax highlighting, and then the rest is like, all this power of Vim is based on text processing, not really like code processing. And so it made sense to me then once I switched back from using IDEs to using Vim.
Yep.
And so I put this idea in my head, like, there's just this unsolved problem that we all like don't have a solution to, which is like idea of having a fast editor that also has the same syntax awareness as the JetBrains ones have. And that was really interesting to me. Like it was my first realization that like, these tools that we all use as programmers, like they're changing all the time. And like you can just make up your own stuff. And so, I guess at the time, like a couple of years into working at Pivotal, I guess I was looking for something like hard to work on, or just something different than like the app development cycle that I was in.
Yep,
And I still had that thought about, incremental parsing, like, is that a thing? And so I started kind of on the side, mostly in the mornings when taking the bus from Oakland to San Francisco, I would sort of do my research about this idea, like, what would it take to make that happen? And I had this vision from early on about it, where I wanted to. I really admired these certain software projects where like it seemed like they were solving like a dense, hard problem like that, and like kind of making it sort of fade away. Like once it had been solved by this library, like you just didn't even have to worry about it anymore. Like SQLite was kind of like the number one thing like that to me. Like it was this C library that like if you wanted like a managed structured data, like you just use SQLite, and it completely solved the problem. It was non-problem anymore, and it was this really gnarly thing that it solved. And like other things like that, like libgit2 was a similar thing, where it's like, you want to do Git stuff? Just use libgit2, and you can do it from any language because there's bindings to the C library. And so I kind of had it in my mind that like, okay, well, I should figure out how parsing works, because I don't know that, because I never went to computer science school. And then once I do that, which then I have to find out how you do incremental parsing, but there seems to be papers about it. I don't understand them yet, but I'll read those once I understand parsing. And then if you could just do it as a C library, then it would be like solved. And you could put it in an editor like Vim was kind of like the end game at the time was like, well, if it's a C library, you could even use it in Vim or any editor. You could like portably solve it. And so that was like this long-term plan, but I had to start from like, just how does parsing work? Like what are the like basics there? And so I kind of worked backward from trying to like read what academic papers existed in the computer science literature about incremental parsing. And they were all kind of older, like from the 92 or something like that. And this was 2012 that I was starting on this, I think. And so they were a bit older, but I didn't understand them yet, but I wanted to scan them and find out like what were the things that they built upon, so I could go learn that and then come back to them. And so, I think I found out that all the incremental parsing work that was like proven and researched was based on LR parsing. And so I thought, that's what I know that's what, Yak and Bison use. So I should go learn how that works.
Yak and Bison are parser generators, right? Like
like the old school Unix one, Unix parser generators. And so I kind of read up on those, mostly using like my go-to was just the Wikipedia pages about them, and then also trying to just take what I did understand out of that, which is like a subset, and implement it. And then see like what didn't work, and then that was what cued me that I needed to understand like the rest of the article, like kind of gradually filled it in with a broken implementation. And
I love this. I just want to say I love this because the two things. Like one, you're teaching yourself all these sort of things that are like kind of the fundamentals part of computer science, which I feel like there's this perception out there that like that's the thing you still have to go to, a 4-year computer science degree to get, right? But here you are just like learning all this stuff with the power of Wikipedia and in the internet on your own. And then two, it's almost like you chose to tackle this problem that I feel like a lot of people I've spoken to who've been through, 4-year CS program are like, oh no, that would be too hard. Like, if it hasn't been done by now, there's a reason it hasn't been done. Like parsing is hard, compilers are hard, but it's almost like, you with your fresh eyes, you're like, well, why not? Like I have this problem and it seems like this is a viable path, and why not go down this rabbit hole?
Well, I might not have done it if there wasn't at least some paper that said like, so this guy, Tim Wagner, like proved his algorithm correct, and just, so that was what, like, it wasn't like I was like completely like, walking in being like, oh, I could figure that, or, I can prove that this is possible. I didn't know it was possible because like someone had in academia had like proven it, or supposedly proven it. I didn't, understand the proof at that time, but they just had never, they like graduated from their PhD and then they like went and did other things. So I was like, oh, okay, well, all someone needs to do then is just like implement what they said and kind of turn it into more of like a modern library type of thing instead of being this like sort of complex interfaced C++ project. Like just turn it into like a simple interface thing, and then you'll be good. And so that was what gave me the confidence to approach it. Was like, okay, it's been proven but hasn't been implemented, so all I got to do is like popularize it.
Yeah. So you had this idea in the back of your mind, and was this what prompted you to go to GitHub, or was this something that you kind of carried with you when you joined GitHub and later came to fruition?
I worked on it for quite a while before I moved to GitHub, but what did happen was Nathan, who I'd been working with and who I talked about earlier, he moved to GitHub, and he was basically a founding member of the Atom team at GitHub and kind of was working on that for a while. And so I knew that he'd told me how he had always wanted to build a text editor, and so I knew he had gone off and done that. And I knew that with Atom, they were sort of taking this. They had this specific goal of making the hackable text editor based on web technologies. But I stayed working at Pivotal for a while and just kept on working on TreeSitter on the side. But I think one thing that eventually prompted me to quit there and start working at GitHub, well, there was a couple things. There was one was that I saw it, they kind of let me beta test Atom, and I remember trying it at the time and going through. They had this Atom was really rough, but what they did really figure out early on was how you would write packages for it. It was almost it wasn't yet that good of an editor by itself, but the experience of making a package was super smooth. You could run the tests with this built-in command in the editor. And there was already stub files for how you would do your CSS and stuff. It was all set up for you. And so I thought that was really cool. So as soon as I got that beta came out and I got on the list for it, I said, okay, now I'll take TreeSitter in whatever its current state is, and I'll do a Node.js binding for it because that was, Atom used Electron, and so Node.js was kind of their package ecosystem that they were drawing from. And then I'll hook it up and I'll see, that'll be my first way that I can actually run TreeSitter live while editing and see how it works. And so I built a simple package that all you could do was it implemented the extend selection command from JetBrains editors, where you can hit Alt up or something and your selection grows to grab the next syntax tree node in your source file. So that was really exciting to me. And then I kind of put that to the side. But then another thing that happened is we were expecting our first kid, and the lifestyle, up until then, the Pivotal Labs lifestyle where it's full, you're in person all the time, no remote. And it's everybody used the same schedule, 9 to 6, and you were in person pairing the whole time.
Yep.
And I loved that. It's a really fun way to work, but all of a sudden I started kind of not wanting to do that. I wanted to be home and able to help out with things, and I was kind of seeing that coming, even though the kid wasn't born yet. And so it was all of a sudden I realized, because I was seeing all the benefits of pairing all the time at Pivotal, but I wasn't really until then experiencing why you might want a different workflow. And so all of a sudden I understood that and I wanted that. And then at the same time, this stuff with Atom was happening. And so that was when I applied to work at GitHub and ended up joining that team. And that was and like I said, one of the reasons was to have this different working schedule, and it was such a big change coming from working at Pivotal, where you're like literally talking out loud all the time to people, to GitHub, where I would occasionally go commute to San Francisco from Oakland still and go into the office. But even once I got into the office, it was still just everyone kind of working in their own corner of the GitHub office. GitHub at the time, like the office
quietly
was like
typing away,
all bars and coffee shops, and everyone was just picking their corner, typing away.
Nice.
And I remember being so just unfamiliar with that at first. But what I loved about it was like the independence that you kind of could work with. At the time when I joined, the Atom team was like, it was pretty small, and everyone on it was pretty experienced developer at that point. So everyone it was very much like everyone had their branch. It was kind of this infrequent code review.
Yeah.
People worked on whatever they thought was important to at that time. It was just super independent and self-structured. And I remember loving the PR review process at first. I hadn't really engaged in it much before, because when pairing all the time, there isn't as much of a need for doing code review. But on the Atom team, we would, there were even already all these Atom fans on the internet who were following all the pull requests. And so like you kind of had this audience to write for. Anytime you made a code change, you'd have to write up this really nice technical description of it. And I remember loving that at the time and thinking, oh, wow, this is so different from pairing, where I just casually say everything. It's like technical writing is a part of your job, and you have to describe everything. So, in this batched way. So that was really cool. But then, what changed though about that was that we hired more people. The Atom team grew. And so we had a little bit more of a mix of people with different coding experience levels on the team. And then also, really importantly, Antonio joined our team. Antonio is, he and I and Nathan are now founding this new company together, and we've been working ever since this time. And Antonio, at the time he joined, he just sort of found the Atom project on GitHub and started contributing these really deep technical improvements to Atom. But Antonio lives in Italy. And so like there was like no way anymore to have very much of a synchronous conversation.
Time zones.
And at the same time, we started working on things that were, not that way, where everyone has their own branch and we're all just sort of working separately and reviewing each other's code, where there was some big hard project, like we needed to rewrite a certain data structure in C++, or we needed to optimize something. And it took Nathan and I and Antonio started not wanting to just have our own branches and work separately and review PRs. We wanted to work together, but the only flow that we could make that happen with was we would kind of have this continuous handoff, where I would leave and I would just type a long message in Slack being like, okay, the code is not totally compiling. This part is broken. I just decided to change this to this. Here's why. It was really, very different to the PR review workflow.
Oh, wow. So you would hand off these things while they're still work in progress. They weren't
the same branch. Yeah. We'd all,
the same branch.
We would just continuously be working, and one of us would get up, and by the time the other one of us going bed, there'd be this short overlap. And the only way, and that's how we work to this day on Zed now.
That's crazy.
But
wait, so do you walk the person who's picking up where you left off? Is there any live conversation in the transition point where you're here's what I did and blah, 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 and watch out for this because this is a big hack? Or is it just you write the message and you're all right,
we try. Yeah. On One Direction, we did have that. When I was getting up in the morning, or Nathan was getting up in the morning, Antonio would stay up late enough so that he could speak to us.
Okay.
Because it would be the late evening for him, not crazy middle of the night. Yeah. But the other way around, when Antonio was waking up, nobody was there. So we just had to write this pretty like complete description of and we would try to not leave it broken, but we often did. And so we had to just explain everything in Slack and be pasting code into Slack. And so it was like the most effective way we could find to work together, but it was, still challenging to have to write that way. And it wasn't, we didn't really use GitHub code reviews for that because it wasn't like, it was all on the same branch, and it was like what we were having to capture was not like, complete state. It was just where we left off.
Yeah.
And so, I don't know, that was a point when I realized, none of our collaboration tools are quite addressing this problem right now of this process. But like, we made it work. I don't know. Maybe I should fast forward at this point to other things.
So I guess like I think a lot of this is kind of foreshadowing, at least from my point of view, like the eventual creation of the company that you all started together, Zed, right? But before we get there, I just want to finish the time at GitHub, and I'm curious as to like how TreeSitter got to be incorporated into Atom and different parts of GitHub's architecture. Because in the beginning, you just made this kind of extension or package for it. It was like this toy, and it wasn't really doing much. At what point did it find an application inside GitHub?
Yeah, it took a while. Fortunately, that we had this company summit where we all flew to San Diego and we stayed in a resort together, and there was this GitHub.
How big was the company at this point?
I think the number of software engineers at the company was around 150 or something. So there was a lot of people I didn't know because I'd really only met the Atom team, which was this small kind of island. And Rob Ricks was a GitHub, had been at GitHub for a while, and I didn't know him, but he kind of went up on stage in front of all the software engineers at the company and wanted to pitch this idea that we should be doing parsing of the code on GitHub and try to build kind of productivity features that made use of the parse tree. And so I sort of, after that, he gave that talk, I had to just go and find him and say, hey, I really think we should do that too. And I've been working on this parsing framework. It's a little bit, my focus was on text editors at the time, but there were a lot of common design constraints for like a text editor and also for github.com, because they're both these tools where the tool creator don't know a ton about the code that the person is viewing the tool. We just know the file extension. Yep. And there's a lot of different languages that we want to be able to plug in. And the parsing just needs to be really fast. In an editor, it's because your display is updating while you're typing and you need to see that. But in GitHub, it's just because there's a lot of pushes per second. And so the parsing needs to be really fast. And so I talked to him, and he kind of got set up with TreeSitter, and they were doing code analysis in Haskell. And so they kind of quickly created a TreeSitter binding for Haskell, and they created, they explored a bunch of ideas about doing stuff with diffs. But what eventually shipped was this first version of code navigation in GitHub that was, it was still simple. It was kind of similar to C tags, where it's not doing a semantic analysis of the code, but it's just finding functions and finding classes and types and finding call sites to functions and matching them up by their name. It was at least better than C tags in that it could also, you could find not just the definitions, but call sites as well. Although newer versions of C tags, I think, might do that as well.
This was back in 2015 or something like that?
Yeah, I started working at GitHub end of 2014. I think this might have been 2015 or 2016 that this.
Okay.
They started working on this, and I was kind of involved from afar. I would help them debug tree sitter stuff, and they were working on grammars that made a bunch more grammars for Ruby and PHP and Python.
Yeah.
But it was kind of separate from me. It was cool because it was this project that I had put all this like time into, and I cared a lot about, and we weren't really ready to use it on Atom yet, just because we had other product features that the team had prioritized, but this other team at GitHub was like, getting use out of
awesome.
it. So that was nice. And then finally, it was almost like, through helping them with tree sitter, it helped, and them working on grammars, it helped the tree sitter mature enough to where it got to where that it could highlight JavaScript and be more reliably than the TextMate grammars that we were using in Atom. And it would, it was more efficient. And so once we got to that milestone of like, the highlighting is better and it's faster, then we finally incorporated it into Atom.
Awesome. And the thing it was doing in Atom, was that code navigation as well, or was that more on like the syntax highlighting side?
We were just using it for syntax highlighting and code folding, so you could fold functions that weren't necessarily indented in the way that Atom previously had required them to be. And also that command I mentioned earlier, extend selection. We made that a built-in feature of Atom, so you could grow your selection up the syntax tree. And for me, that was it's funny. It's such this unassuming feature, but it was this feature of the IDEs that I had used to use a long time ago that I had loved so much. With you could put multiple cursors on different codes that you wanted to refactor and grow them all up the syntax tree so they would all be selecting the right thing and then do a refactor.
That sounds really satisfying.
Yeah, I love the feature. It was so it didn't have a huge bang to it, but I just loved it.
That's awesome. What about Tree Sitter as an open source project? Because now it's popping up in a lot of places. I think more and more people are using it inside other editors and building on top of it. I know GitHub continues to build on top of it for their code navigation. Have you kind of kept up with the goings on of the project and where it's being used?
I do. Yeah, I try to. At the time when I was, it's been taken up gradually by more and more. I hear about companies that are paying people to work on grammars and parsers and stuff. A big one was SemGrep, the code kind of they make tools for searching for certain patterns, and especially anti-patterns in source code and correcting them. They switched to using Tree Sitter, and then one that made me really happy, even though I've kind of moved on from using Vim, was that NeoVim incorporated a built-in feature of NeoVim that you could parse your code with Tree Sitter. Yeah. And what really, I think, was the final thing that helped more people find a use for the library was that we built this, was that eventually I left the Atom team while still at GitHub and went to work on the code navigation thing full time. And we built this one more feature in Tree Sitter that was about searching for patterns in a syntax tree. And our goal was to make it so that you could have kind of one engine that was like a pattern matching engine in the syntax tree that would both let us do syntax highlighting. By you'd be able to say there was a language that was kind of based on S expressions like Lisp, where you could say you could look for a function containing a return type of blah, and you could syntax highlight that, and then we could use the same engine for matching things like that for recording function calls and definitions for code navigation, and we just called it tree queries. And that something, when we built that, it was it finally became if anyone wanted to do syntax highlighting with Tree Sitter, it would be more like a one-line thing now that there was that system, and people could use the same tree queries, even if they were using Tree Sitter from different application languages. Like NeoVim was a C code base, and then GitHub we had Go/Rust/C code base. But we could all use these same queries to find the patterns in the trees. And once that sort of layer was like moved down into the tree sitter library, then NeoVim could really easily do highlighting, and people made plugins for other text editors to do highlighting. And I think that a lot of people started using that, which was really cool to see.
Yeah, that's awesome. I think the code navigation application is particularly interesting because obviously, Sourcegraph has its own code navigation implementation, but it's kind of interesting to think about like the different technical approaches that we've taken versus what GitHub has taken.
Yeah, it's really interesting. GitHub has like taken it's definitely a difficult path, like trying to kind of build your own code analysis pipeline that's not feeding off of existing compilers and stuff to do the code analysis. And it's tough. It's like GitHub has this. It's like for GitHub, there's just sort of different. I think what you're doing at Sourcegraph it's almost like it's very easy to see why that approach makes a lot of sense. And for GitHub has this like interesting different value of different features where like being able to do something ecosystem wide is like almost the only thing, or not the only thing that matters, but it's like if a feature isn't ecosystem wide, it's like it's not going to hit that strongly on GitHub compared to where like Sourcegraph, if you got your company's code base and you're trying to search that, you're fully capable of setting up a little compiler CI pipeline where you run your own static analysis on your code base and all of your own dependencies and stuff.
Right. Because GitHub is starting from this point of view where like whatever code navigation they provide, they want it to work across as many languages as they support as possible, and regardless of whatever like build configuration you encounter. I think that's a lot of the like trickiness of this problem. It's like different languages and different build systems. And so the tree sitter approach is nice because it's sort of this like, I mean, it's not like language agnostic to the point where like one grammar works for all languages. You have language specific grammars, but it is like one kind of parser generator. And then you're not like fully compiling each language, and you're not trying to be build system aware. It's almost like you get 80% of the way there in terms of accuracy with hopefully like the set of heuristics that reduce to patterns, right? Like you were saying in the AST for like what looks like a definition or what looks like a valid reference for a given definition.
Yeah, that's the goal of the team, and we I think it'll always be like a lower fidelity accuracy than what the compiler will give you, but it's like sort of trying to operate within this constraint of being able to run on every random repo in a given language that exists instead of having to like have the repo conform to certain conventions. Yeah,
makes sense. Cool. Well, I want to get to Zed because like that's the thing that you're working on now. So, and it looks like from the way you've described your entire career as a programmer, it feels like everything has kind of like built up to this moment in terms of like the way you got into it, through like collaborating and communicating. You're always thinking through workflows, and you have such a deep appreciation for editors and dev tools in terms of like the impact they have on the way people work. So what is kind of the backstory of Zed, and what is Zed? Like why are you building it, and what's it intended to do?
Yeah, so Zed is, like I said, we're founded by Nathan and myself and Antonio from the Atom team. And we're like from the 10,000 foot level, like we just want to build the text editor of our dreams, that we've kind of built up this dream set of features and qualities from working on text editors and kind of programming tools for a while. But it kind of took us it took us a while, but when working on Atom, we were very much like, we started with a hackable text editor that wasn't very polished or good in most other ways, but besides being the most sort of hackable that it could possibly be. And then we tried to evolve it to become fast and powerful incrementally after shipping it and having all these locked in APIs that we had to support. And so we learned from that just so much about how we wish the application worked in terms of like what type of UI framework we even wanted, and what the constraints were of using the DOM or, using web technologies to render the UI. And
thinking about like performance issues, mainly, or are there other like considerations there?
A lot of it is performance. Like we really, with Zed, it's kind of like two things. We want to take a lot of what we learned about the different ways people collaborate on code together. After having, we've all kind of had a mixture of experience from doing these really fine collaboration of pair programming, also doing this really asynchronous workflow of like pull requests and code review. And then this kind of third thing where it's like many people, one branch handoffs, where it's like a mix of the two, and to try to build, now that we know about kind of some of the technologies that are needed to collaboratively code, we built this collaborative coding plugin to Atom that was called Teletype that used, where Nathan and Antonio did this huge research deep dive into CRDTs, commutative replicated data types, and what the most efficient kind of latest greatest flavor
those
of
are
CRDT.
For listeners, my understanding is those are like the data structure algorithm for doing kind of like live updating sort of conflict resolution, like in Google Docs when there's two people typing and sometimes they overlap. I don't know if they actually use CRDTs in Google Docs, but this is a solution for that problem, right?
Right. Yeah. It's one of and operational transform are like the two kind of approaches, and CRDTs require less central coordination than operational transform. And there's been all this work in kind of recent times to make them like efficient enough to use in kind of all the time in an editor.
Yep.
And so after GitHub, Antonio went and worked at this company called Ditto, that was all about like data replication and kind of learn even more deep knowledge about CRDTs. And so we're trying to take what we learned there, and also take what we learned about building just a fast text editor. It was something we all kind of became passionate about when working on Atom, was wanting to make an editor that is just responsive all the time and just feels like it's never in your way to use. And to build an editor that sort of lets you collaborate on code in a way that we have not yet been able to do. That facilitates so the basic idea is, so there's some common features that like exist now in other tools, but like I want to come in the morning when I come to work and not necessarily open up Slack or GitHub, but open up my editor and see who's there, and also see what conversation has taken place. And then be able to look through that conversation and see where in the code it applies to, kind of, click on something somebody said, and be there in the code at that moment that they said that at that time, and also see where that code is now, how it's evolved since then. And, be able to myself on the other flip side, like at the end of my day when I'm handing off to Antonio, rather than like going over to Slack and typing this long thing and like pasting like backtick code snippets in Slack, I want to like click on some code or like go to some code that I'm talking about and just start talking, and like that association between this code at that moment in time and what I'm saying to be captured in the tool or be able to click on a compiler error and start talking about that. And
it's like you're creating this like tour of some recently written code and being able to link to like dynamically into like specific snippets. Is that kind of the idea?
It's linked back and forth, and in a way that's sort of useful in a real time situation where, if we're there together, we just be, instead of typing in Slack about the code, we're typing in the code editor, and we're also simultaneously making edit code changes. But also when we're, when the code for conversations that happen, like at separate points in time, I want to be able to, like right now, if I want to sort of find out about the history of a certain piece of code, I guess what I would do is go to GitHub and there's all these closed pull requests that now have discussion in them about that code at different points in time, but it's hard. Like I would go to the pull request and search for like certain like words that might come up in the discussion. But it's not, I can't just like go to that file and say, tell me the discussions that relate to this. They're different. Today, like comments are on diffs that are committed and pushed. They're not on like just any code, and they're not. And so kind of what we envision is just more fluid, collaborative environment where we can code together. We can both be making edits to the code together when we are both around, but we can also diverge and do our own thing and like just pull each other in when needed. It doesn't have to be this very like intense pair programming situation, but it's a more lightweight pulling in of somebody. It's not like, hey, can you zoom and screen share? Or like, can you fire up this tool? It's just like they're always there. And I'm saying like, one way that we talk about it is like, we're kind of trying to recreate the vibe of like a pod of people sitting next to each other, just sort of casually going over to each other, forming groups ad hoc and then splitting and stuff.
It's like that mind meld feeling.
Yeah.
When you're like hacking with a group of like close knit people.
Yeah. But we're trying to do that for remote.
Yes.
Teams.
Right. Even if you're like in a different time zone, that person's asleep. You want the context information transfer to be as smooth as possible.
Yeah. And then also to make all that collaboration that happens in that close-knit setting discoverable in the future anytime. It's almost like you wouldn't have to-do comments in your code. It would just be so easy to find comments when in code that they could just be comments in this tool. Like I could be looking at some code and be like, why is this like this? And then I don't have to go do a lot of work to dig up the conversation that is about that code. It's connected to it in the tool is our vision.
It sounds like there's a lot of overlap, at least on like a feature basis, with various other things. Like when you're hearing you describe it, one thing that comes to mind is like, pair programming tools like VS Code Live Share, like that allows you to, get into the same editor and see someone else's cursor move around. Or like CodeStream, which was this other, startup that we had in the podcast last season, which was all about like having discussions inside your editor. CodeSpaces also, maybe there's like a web component to this. And the other thing that came to mind was like there's a VS Code extension called Code Tour that allows you to build these like guided tours of code bases. Sourcegraph also has a similar feature. We call them search notebooks, where it's like markdown interspersed with code snippets and search queries. But my sense is that you're not really building this up as like a sum of the features. What you're really after is kind of this like overall like end-to-end solution that captures a certain mode of working that you've kind of, you're uniquely well positioned to have insight into because of like the way that the three of you built Atom in the early days and the way that you've been accustomed to working over the course of your career, this like kind of combination async remote, but highly collaborative, highly communicative setting. Sounds like you're trying to bring that feeling to like every developer. Is that?
Yeah, that's exactly what we're trying to do. It's like the way I kind of think about the like space of tools that kind of touch on this, that like you mentioned, is like, it's almost like when before there was GitHub, it's like you might, if someone said like, oh, we're building a new thing, and it's like you host your Git repos there. It's like you could kind of be like, oh, it's kind of like SourceForge, or like isn't there already that?
Yeah, right.
And it's like there was, but like it turned out that idea of like working together on code just was really big and deep and like and like needed, and there ended up being all these things that came off of it, and it was like such a big change to software development to have something like GitHub that it was like it just took some real creativity and a lot of people trying different angles on it to propose a workflow that in this huge design space of collaboration modes that could exist that like kind of clicked with people. And that's what I want to do is kind of in this huge design space of like taking all this code collaboration into the real time realm, kind of execute this vision that we three have that we think will click for us as a team, and will click for other people who are searching for a more productive way to work together.
Yeah, I mean, like you said, GitHub was not the first collaborative code host. Before that, there was SourceForge, and then there was Google Code, which I remember, using back in the day. But then, like, those were they're just very different because GitHub came along and it was like such an awesome bundling of, I think, multiple really well built applications. Like you had a really good issue tracker that had like good, like well polished features. Like you could paste an image in there and it would automatically, turn that into Markdown. That was awesome. You had a good, code review tool. It worked well with Git, which then was kind of this up and coming new version control system. And so just like combination of that, you threw all those together and it became almost something new, like a place where developers wanted to go to present their code to others and also find other people's code. And so now you want to do that for the editor. I guess my question is like, how close are you to cracking that nut? Like how many more months do the rest of us have to wait before we get to try what you all have been working on?
That's a great question. And we haven't totally figured out how long it's going to take us yet. We're sort of focused on right now. We have a working editor. I wish I mean, what we're tech wise, we have an editor that we're building all in Rust, and we have a custom UI framework that Nathan built a lot of that is about doing immediate mode rendering on the GPU using the graphics card for everything.
Wow.
And
that sounds intense.
Yeah, and then we have this CRDT based editor where it's sort of the cool thing about CRDTs is they actually enable other features too, even when you're not collaborating, like undo. This branched undo thing sort of falls out naturally. Not branched, but like the ability to undo anything, even if you didn't necessarily undo everything after that. And similarly, like redo something, even if you made a change after you undid.
Yeah.
So that's
I know exactly what you're talking about. I feel like every developer,
yeah, like you better not like you undo, better not type anything, otherwise you won't be able to redo. So we have got this really fast editor that is based on, it's sort of always a CRDT, and so you're kind of at any time ready to start collaborating. And we have Tree Sitter integrated, so it's right now we're just using it for syntax highlighting and code folding, but we'll kind of be prepared to just build nice, subtly syntax aware variants of any feature that we want to build. And we have sort of a basic collaboration system going where we have a server that's also written in Rust, and it's kind of fully integrated with our editor client. It's kind of right now it's like a mono repo, and they share code. And so we have this fast ability to collaboratively edit documents. But there's a lot of stuff you need to build to make a text editor actually useful to people. Stuff that's just pretty basic, like, a tree view of your project and like just all kinds of things, spell check, markdown preview, language server integration is a big one. We want to ship. Our first ship is going to be we want to nail the experience of editing Rust in Zed first, just because we use Rust every day, and Rust has an amazing language server that has been built, Rust Analyzer, and we kind of understand the way that people work when writing Rust, which is often make a change, 100 compiler errors occur, and then you burn them, you go one by one and fix them all. And the compiler tells you, it's kind of like compiler driven development. And we have ideas about kind of workflows too, innovations we want to do about how to make that experience of coding Rust in Zed really delightful. And so that's what we're kind of focused on right now. It's we've built out a lot of the sort of what we think are the high risk pieces, like how the collaboration is going to initially work. But we haven't built as a lot of stuff that kind of already exists in many other editors. But it's just a lot of work to do. So we do need to build all those basic editor features. But then that's our plan, is we're going to ship an amazing Rust editor / IDE that's collaborative in this new way first. And as far as when that's going to happen, that's tough. But I kind of think that next year.
Okay.
Next year we'll have something out.
Well, I am super intrigued, and I bet a lot of people who listen and watch this show are also super intrigued. Is there a place where people can go to subscribe to news or notifications about this new editor that you're building? Yeah,
our website is zed.dev. There's not a ton there right now, but you can, or if not now, we're going to have a way to sign up, sign up so that you want beta access when it comes out, and to get updates, release notes, things like that. So that we'll keep you updated.
All right, cool.
I'll add you to our list so that
yes, please
you'll
do.
Be on our insiders list.
I would love to be an early user. I will give all the feedback that I can, and I think that goes for a lot of people listening in on this too.
That'd be great.
Maybe we can get a sign up link for podcast listeners later down the road. Cool. Well, Max, so thanks so much for taking the time to chat and share kind of your experiences and also what you're up to lately. It's been awesome having you on the show, and thanks so much.
Yeah, thank you so much. It was great talking to you.